Hello, welcome. Good morning, good evening, good afternoon, depends where you're located. My name is Alex, and I'm glad to be here. Right, so just give me something in the chat, like exclamation mark or number 5, or maybe @sign, so I kind of know that I'm perfectly audible, visible, and my screen casts perfectly fine. As usual, we are in we have the chat, so you can drop your questions in the chat. I'll be answering them by the end of the session. But yeah, anyways, feel free to do that. Yeah, hi Matthew. Patiently waiting for 701. Good, good. But 7.0 is also something you can already play with, so no worries. Anyway, let's kick in. So today we are going to talk about the OneDRS. And our agenda for today is just quickly discuss the scheduling, then we go to OneDRS and also show some demonstrations. So if you are following along, then make sure that you have access to your OpenNebula front end. It's accessible. Just in case you need to, you also can establish the secure shell communication to your front end node, and that you have at least a couple of work nodes, virtualization nodes. So just in case you can play with a scheduler, because with one single node, it obviously makes no sense. Right. So the scheduling itself is part of the OpenNebula, and the idea of a scheduler is to deploy virtual machines that are in the pending state, or deploy them or redeploy them when you are rescheduling. So pretty much anytime you are instantiating a virtual machine, it goes into a pending state, then picked up by the scheduler, and scheduler is going to allocate this virtual machine to a specific hypervisor. So scheduler is going to evaluate the requirements field, pretty much to filter out everything that is not matching the requirements. Let's say you want to deploy a virtual machine only to a specific cluster, or you would like to have a specific virtual network attached to this virtual machine. Or, I mean, there might be a custom tag, and you've tagged your hypervisor nodes with a specific tag. Let's say, I know, production and development, and you want to deploy this this virtual machine only on the production nodes. So all that will be considered by the scheduler process, and then virtual machine will be allocated to either of the matching hosts, right? And then, starting with the version 7.0, we have the process called we have the scheduler called OneDRS, so which can which pretty much introduces a different approach to scheduling those virtual machines. Now, out of the box, now we have two schedulers: the rank scheduler, the one that you're all familiar with. If you running OpenNebula for a while, then that's pretty much the scheduler that was always in charge when it comes to deploying virtual machines. Now, then we have this rank scheduler, and then the new one, the OneDRS. Now, currently, out of the box, we are utilizing both schedulers. The rank scheduler remains as a default scheduler for deployments, and OneDRS is in charge when you are optimizing. So when you create a specific plan and optimizing the workloads. So in some of the cases, on some conditions, you may want to leverage the OneDRS for both the placement and rescheduling and optimization. So this might be a reason for you, and it is possible to change. But out of the box, we are relying on Rank Scheduler to deploy virtual machines, and then OneDRS is responsible for optimization. So there's a different approach, and that's why you cannot like pretty much compare one to one, because they serve for different purposes, and then the idea behind every scheduler here is quite different. But yeah, just so you know, by default, we are still relying to Rank Scheduler when it comes to placing the VMs, and then OneDRS is enabled for the optimizations. Now, OneDRS is obviously something new, right? And OneDRS is the distributed resource scheduler. So it's OpenNebula distributed resource scheduler. That's why we call it OneDRS. So the idea that it can optimize the resources, optimize the resource allocation. So it prevents some scenarios when, let's say, you don't want your virtual machines to fill up a specific host, or fill up only a few hosts, and then some of the hosts are remaining untouched, or vice versa. You may want to make sure that you are maximizing the usage of a single host or single hosts, and then keep as many hosts unoccupied as possible. So the OneDRS integrates with the built-in monitoring and forecasting system. So again, something that in 7.0 can be found is the forecasting system. So it can consider the real-time metrics, as well as it may consider the predictions that are made by the forecasting system. So as the administrator, you are in charge to define should it take any predictions into consideration when supplying a plan, or it should solely rely on the current metrics, or fully rely on the predictions. So you pretty much can balance what is the approach you wish. So OneDRS is using the integer linear progression solver to optimize the cluster workloads. And it's packed with the open source solver out of the box, so you may leverage that. In some conditions, or if you have license, for example, for commercial, you may go with the commercial one. But once again, it's already a deeper fine-tuning and fine-graining. If you need to, then feel free to go that route. Out of the box, there is the solver that is responsible for helping to generate a plan, and it's packed with this one. So there are a few config files, and the one is etc1.1d.conf. So this one is the general OpenNebula config file. You may already be familiar with that. And that's where you can set which scheduler is in use for general allocation, right? So whether it's the rank scheduler, or we are proceeding with OneDRS for these allocations. Another quite interesting thing here is DRS interval. So by default, it's set to 10 minutes. That's basically how often the distributed resource scheduler kicks in to execute the automated actions, right? You may completely disable it. So just put a -1, and then it's going to disable the automatic invocation of the DRS. So the thing with DRS is that it can work in 3 modes, right? So it can work in fully manual mode, and that's when you request the plan generation, then you are applying the plan. Then it can go in partial automated mode, where the plan is going to be generated automatically, although you will need to pretty much approve and apply the plan, or you can go in completely automated mode, right? So the DRS interval is the one that takes care of the partially automated and fully automated actions. And then we also have the main OneDRS configuration file that is etc. one schedulers one_drs.conf. So let's have a brief look on this one. So once again, we go, let's say, to with VI less nano, whatever floats your boat, folks. So then it's going to be etc. one, then schedulers and OneDRS.conf. Right, so that is, again, in the schedule directory, you may find also the rank.conf. So this one is responsible for rank schedulers, scheduler configuration. So now we have 2 config files when it comes to schedulers. It used to be only 1, now we have 2, right? And now this one pretty much configures some of the default behavior for the schedulers. So first thing first is the solver. Once again, if you need to use any other solver that is supported by OneDRS, then that would be where you can configure that. Then we have 2 settings here. These are quite important here. So first one is place and second one is optimize. So these are the default settings for placement and optimization. Since by default, we are relying on rank scheduler instead of OneDRS for the placement, then this pretty much, it doesn't matter. What actually matters is this one. So optimize, right? And then it sets the default settings for the optimization. So optimization policy is either balance or pack, and that's pretty much where you make a decision how you would like your environment to be optimized. Either you would like to pack all your virtual machines as close to each other as possible. So then you are pretty much willing to use less hosts, right, and keep some of the hosts pretty much unoccupied, or you go with balance, and balance policy pretty much balances the load of your environment, so utilizes more hosts, but not at every host maximum. Now the migration threshold set to -1, which is also known as unlimited, or no limits, pretty much migration threshold. Now, what the migration threshold is, that defines how many virtual machines can be migrated in the scope of one optimization plan. -1 means unlimited. So if you need to migrate thousands of VMs, then 1,000 of virtual machines are going to get migrated. Now, you may want to limit that. Reasons different, like the disk I/O, network throughput. You like just to have, let's say, more plan executions than just do it in one single batch. So it's up to you, right? But that's pretty much where you can set how many virtual machines are going to get migrated in the scope of single plan. And then the weights, this one matters for the balance policy. That's where you define which metrics to take into the consideration, like the CPU requested, the CPU usage, the disk or network or memory. So that where you define what are the weights. So that's the configuration file, but in most of the cases where what you are going to configure is the cluster policy in the graphical UI. So that's why I would invite you to switch from the command line to the Sunstone, right? So use whatever, user you have, but I'm going to proceed with one admin. I haven't altered anything, so I'm running with the default super admin user called OneAdmin. Right. So the DRS itself works at the cluster level, which means like the policy is going to be cluster wide, not the environment wide, not the zone wide, but the cluster wide. That's why you would need to configure OneDRS policy from the cluster view. Although before we are going to create any policy or play with any optimizations, let's firstly deploy something so we have VMs to optimize. And for that, let's proceed to the storage apps and let's grab the Alpine Linux from the marketplace. So make sure that you're selecting the correct architecture, right? So we don't, at least in my environment, I'm not going to use the ARC64. I will proceed with standard AMD 64 architecture, right? So Alpine Linux, the most lightweight, faster to get, faster to deploy, works for us in this scenario. So let's press import and let's place it on the default data store. So we have the virtual machine image, we have the virtual machine template. So I'm not sure what kind of resources you have, but my resources are not, I don't have a lot of resources, let's say it like that. That's why I will need to fine tune the CPU usage, so I can, just in case, I can deploy a bit more virtual machines than I would, let's say, do if that host would be in the production. Also, by default, I would like all my virtual machines to be deployed on a single host. And there are multiple ways how to do that, but just to make it easier, select 2 hosts if you have 3 hosts, select 1 host if you have 2 hosts, and click disable. Right? So let's disable 2 hosts so virtual machines are not scheduled on these hosts. So that's how I will be able to fill in 1 host and make sure that these 2 remain unoccupied. Right. So then let's proceed. Let's go to the virtual machine templates. Let's find the Alpine Linux. Let's select it, click update, and let's adjust the physical CPU from 1 to 0.1. Once again, in this test scenario, I would like at some point to deploy maybe more virtual machines than I would do in the production, considering the same hosts. So that's why I would like to lower down the physical CPU usage of this virtual machine, and the rest should remain as is. Right. So let's go back a few steps and do the checkbox. So we have 2 or 3 hosts. Once again, you may have 4, 5, 10, whatever is your test bed. Mine is this. So have a couple of hosts. all but one are currently disabled, so no virtual machines can be scheduled automatically on these hosts. We have Alpine Linux virtual machine template and Alpine Linux image, the most lightweight one, and we've adjusted the physical CPU usage from 1 to be 0.1 to make it even more lightweight. Right, so now let us schedule some virtual machines. So press instantiate and number of instances. So again, depends how many you would like to deploy. That pretty much depends on how much resources you have. I have only 12. I'm going to deploy only 12 virtual machines in this case. Although, I mean, if probably we would have a bit more time, I would proceed with 40, and then we'll reschedule, we'll optimize 40 VMs, but I just don't want to take too much time. So let it be 12. Nothing should be altered here. Let it remain as is. So let's click finish. All right. So I have 12 virtual machines in the process of deployment. As I said previously, Rank Scheduler is going to take care of it. So the good old tested, perfectly fine working scheduler is going to pick them up. And one by one or two by two, it depends on the settings, these are going to get scheduled on the same host. So if we are going to if we'll navigate to the hosts view, you will see how slowly but steady the one of the hosts, in my case, the host with the ID 2, is receiving the virtual machines and getting occupied more and more and more. So all virtual machines right now are spinning on this host. Right, and if we go to the VMs view, you can see that currently these 12 VMs are deployed. I mean, obviously, you can click the VNC and check out the VNC to see that these are also up and running. So pretty much we went through from have no VMs to have 12 VMs. In my case, you're maybe 20, 10, 5, 25, again, whatever is your environment. But in my case, and if you follow along, and if you have more or less the same infrastructure as I do, then 12 might be a sweet spot. All right, cool. So what's next? Of course, enabling the OneDRS. So as I mentioned before, OneDRS operates at the cluster level. So then the policy should be created from the clusters view. That's why we navigate to clusters. By default, we have only one cluster, which is default. In your production, you're supposed to have more than one. So then they may have different OneDRS policies. But again, in this test environment, I have only one cluster, so I will operate with the default cluster. So let's make it full screen so it's easier to operate, and go to OneDRS. By default, OneDRS is not enabled, and there are no plans, no reschedules whatsoever. So if I would like to enable OneDRS, I need to click this button, and this is going to pop the policy out. So let's click OneDRS, and you're supposed to see pretty much the same screen. So you have the migration threshold. That's where you set up how many virtual machines can be migrated within the same in the scope of a plan of the same plan, right? Then this is the slider that tells how much OneDRS should rely on the forecasting values and how much OneDRS should rely on the currently gathered metrics, right? So by default, OneDRS makes all the decisions based on the current latest and greatest metrics and nothing from the forecasting side. So by moving this slider to 100, that pretty much tells that OneDRS supposed to make the decision fully based on the forecasting, not on the actual metrics. Then we have the policy and automation. So automation, as I mentioned before, you have three options: partial, manual, and full. Manual, you request the plan, you execute the plan. Partial, the plan will, well, partial is kind of where plan will be generated based on the OneDRS interval. And then you're supposed to apply it manually, but you also can request it. So if that's probably what we are going to do right now. We're going to set it to partial and then just request the plan to be generated. And then full, that's pretty much the relax, sit back and enjoy the flight, where you just completely give the all decisions to OneDRS. Again, whatever is your case, you may test it a couple of times in, let's say, partial and then switch to full. Or if you're more on like a control freak side, then you go with fully manual. Or if you're like me, a little bit of a control freak, but at the same time, sometimes you like things to be a little bit more automated, you pretty much go with partial, right? So let it generate on its own, and then I will apply it if I feel like that. And then the policy. This one is pretty important, right? The pack policy will stuff all the virtual machines on the same host until it's filled and then goes to another one. Or balance, right? Where you try to load balance your environment. So by default, the pack is selected, but let's go with the balance. Why we're not going with pack? Well, that's because my current hosts are, my current virtual machines are fully on the same host, so the pack makes no sense, right? When you select balance, you may fine-tune the weights, right? So define what is the most important when OneDRS crafts a plan. So should we take the CPU in the consideration, and let's say memory? Should we take networks into consideration, or as it is, solely make a decision based on the CPU, right? So totally up to you how to adjust that. By default, 100% goes to CPU. And my hosts are the same. So that's why pretty much it's going to be load balanced, more or less. Right. So once again, whatever floats your boat, adjust the weights the way you feel it's necessary. And then you just accept it, right? And that's it. So the plan is there, not generated yet because either I haven't clicked optimize, or secondly, the internal timer, like once in 10 minutes, not yet kicked in. Another thing that we need to do, that's something that I actually forgot. We need to go back to hosts and enable these two hosts, right? So let's enable them back. So now they're back in the game. So yeah, otherwise it's kind of pointless because pretty much one host is only running and then nothing to optimize. Okay, let's go back to clusters and let's go back to OneDRS tab. So we have the migration threshold -1, and then that's pretty much means that all virtual machines can be rescheduled if needed. So you can do either wait for like 600 seconds or 10 minutes, or we can click optimize and give a task to OpenNebula to create a plan. So what you should know about the plan is always the latest and greatest, right? So whenever you see the plan, that is the latest plan that was generated. So currently there is no historical history of these plans. So in the web UI, you'll always see the latest and greatest plan. Now, if you would like to kind of look into that a bit more, you may increase the verbosity of the 1D and then look for that in the 1D.log. Although I would really suggest you to do this only when you probably experience some issues or something like that, because on its own, running the 1D with the highest possible verbosity is not the brightest idea. But yeah, so if you increase the verbosity, then also plan is going to get outputted to that log file. But by default, the latest and greatest is always the one that is visible. So it may take a little bit of a time to generate the plan, right? Because depends on the environment, might be a rather complex task or might be a rather easy task. Right, so what we can see here is the plan, and it's not yet executed. Why? Because we have the partial automation, right? So it's not fully automated. And we can see the plan, so the operations. It means that these virtual machines are going to get migrated to a different host. And I can kick in the task by just clicking apply. Or I may update configuration and say that I would like some other metrics to be there, or I would like, let's say, instead of balance, I would like to return the pack, or, well, I want less virtual machines to be migrated, instead of, let's say, migration threshold instead of unlimited, let's go, with 5. So I did some changes. Now I need to build a plan once again. Now this time is faster, right? Because that's pretty much the only change is the number of virtual machines to be migrated within the same plan. So it just shrunk it to 5. And then I can click apply, right? So let's click apply. And again, another warning that you really would like to apply the optimization plan. So it's, again, quite important because it doesn't matter in my test environment, right? And probably when you have 5 VMs to migrate, it doesn't matter that much. But let's say if you try to optimize, you have unlimited as the migration threshold, and you have thousands of VMs, and now you have a plan to migrate, 500-600 of virtual machines. So first thing first, some applications might get disrupted during the migration because, let's say, you haven't enabled the live reschedules, so there's only a cold migration, or maybe your network would be kind of saturated for that period of time, or maybe your disks are not that fast and cannot accommodate that many migrations. So you may want to have this yet another button to accept before you actually will kick in the migration process. That's why I would consider this as a safety feature. Okay, are we cool with that? Yes, I'm pretty much cool. Let's proceed. Okay, so, and now the OneDRS handed over this task to the 1D, and 1D is going to take care of all the necessary migrations. You can observe the plan, so we can see that 2 hosts are in the process of applying, right? And then we have 3 are ready to be migrated, ready to be applied. Although As well, you can go to virtual machines and you can observe your virtual machine state. You can also tail the log file, and then you would see the log file that shows that virtual machine this is currently getting migrated to that host. So yeah, that's pretty much observable if you wish. But obviously, always give it a little bit of time to perform this task. And then when the migration had happened, you would see this in the done state, right? So that means that the migration is successful. And if we go to hosts right now, you can see that it's more or less balanced at the moment. Of course, we still have this host to that's pretty much more saturated than the others. But once again, why it happens, it's because I set a threshold to 5. So instead of migrating 9 virtual machines or 7 virtual machines or 8 virtual machines, the OpenNebula could only take 5. That's why. But once again, if we go to clusters, we go to OneDRS, and we click optimize, or it was the plan was generated based on the timer, and you can see that there are 3 more to be migrated as well. Okay, so let's do it. Why not? Let's apply and let's see how it goes. So once again, give it a little bit of time to perform this task. Depends on the virtual machine size, depends on the overall speed of your network, and obviously depends on the speed of your hosts. It may take either a few moments or a little bit more. Right. So obviously we can go to hosts and we can see how some of the hosts are getting free, while some of the hosts are more and more getting more and more occupied. Right. So same goes with pack. If I would like to pack all the things back to one host, so I can go and update the configuration, go from balance policy to pack policy, accept this thing. Obviously, sorry, I would like to update and set it back to unlimited this time. Right, click optimize, get a new plan. And as you can see in this plan, we are going to migrate 8 virtual machines. And in the host, the target host is the same host across. Now I have a total of 12 virtual machines. We're going to migrate 8 VMs because 4 VMs are already there as the result of our previous optimizations. Okay, let's apply. And let's see how the host is getting more and more occupied. So that's this one, the host with the ID of 0. And we can see that some of the virtual machines are already migrated from the host with the ID 1 to the host with the ID 0. Once again, since like pretty much everything goes to one host, it may take a little bit more time than distribute the load across the whole environment, as that's pretty much the bottleneck right now is one host. Like everything flies back home to that one host. Right. And regarding the forecasting itself, once again, you can make this decision based on the forecasting metrics, right? Based on the CPU load, based on the forecasting metrics. You can also fine tune the forecasting should you need to. So there is a dedicated config file. So you can find it under the var lib 1, remotes, etc. IAM, which stands for the information management driver. So kvm-props.d, and there's going to be the forecast.conf. So the forecast.conf defines some of the variables for the forecasting, for the predictions, and a few are quite interesting ones. The ones is the period, so the forecasting horizon, and also the look back. So for like how much in the past we should look to get the prediction, or let's say next 5 minutes. So we have two types of forecasting. We have the short forecasting, which is by default 5 minutes, and then we have the far forecasting, which is the forecasting horizon for 1 month. And then when it comes to look back, so we look at the recent 60 minutes for our short predictions, and for longer predictions, we are looking for like the 60 days in the past and their metrics to create these predictions. So all that can be fine-tuned right here, and forecasting is something that OneDRS is going to rely on if you will move the slider of the forecasting further right, and then take the forecasting into the account, into the considerations. And once again, as you can see, we have 12 VMs. All of these VMs are currently occupying the host with the ID of 0, and then the 2 can be, let's say, once again disabled or brought offline, and so on. And if you don't need for these tasks to be carried out again, you can go and disable the OneDRS on the cluster, and it wipes out the plan and is excluded from any planning in the future. Right. So that actually took me less time than I initially planned. So yeah, any questions, I'll be glad to answer. Don't forget, just in case, we have our community forum where you can ask your questions should you, I don't know, come to across some of the issues in the future. Don't forget that you can attend other webinars either by myself or by my amazing colleagues. Obviously, yeah, this session is getting recorded. So if you didn't want to follow along, or if you forgot to prepare your environment, you can return back and check out this recordings and then follow along. Yeah, and if you have any questions regarding the topic that was covered today, feel free to drop it in the comments. Well, I hear no questions. I see no questions. Thanks for attending. I hope it was educative enough. And once again, we'll see you in the next session, and have a good reminder of your day. Bye bye.